All right. Welcome everybody to week 6 of our Space Club Career Chats. We're so excited to have you guys here. We're so excited for you guys to hear our speaker for today. So again, Space Club Career Chats, your mission control, Natasha, wave hello. And then my name is Aspen Meineke. All right. And so our guest speaker for today, so if you guys watched this week's video that we have linked on Goose Chase, you might recognize him. So his name is Syed Ridhwaan. He is an engineer for the Perceptive System section at the Southwest Research Institute in San Antonio, Texas. And his Bachelor's of Science is in Computer Systems Engineering from Arizona State University. And before I bring him on really quick, everybody just remember like protocols that we will not be calling on any students during this. So make sure if you have any questions to put them in the Q&A box, and we will be looking at them as we go through our chat, and we'll be picking one or two to ask him at the end of our career chat. So make sure if you have any questions to ask him as we're talking today, make sure to put them in the Q&A box. So Ridhwaan, if you would like to jump on and just say, just tell the students a little bit about yourself.
Hey guys, how's it going? My name is Ridhwaan, and I graduated from Arizona State University about 4 years ago with a bachelor's in computer systems engineering. I had a lot of fun there, learned all sorts of things, and I moved all the way from Arizona to San Antonio, Texas to work at the Southwest Research Institute. So I work in Division 10, which is intelligent systems, and in that, there's another smaller section called the perceptive systems sections, and that's where I work. I mostly work with sensors, but we work on things from deep sea to deep space and all sorts of fun projects.
Nice. Awesome. So we will jump into all the student questions that we got. So the first one is, how long did it take for you to get a Bachelor's of Science in Computer Systems? And this question is from the Galaxy Was Not the Imposter from California.
I love the name. So funny question. I did get it within 4 years, which is about average for most people. Some of my friends get it take a little bit longer, some a little less. But I did switch my major about 4 times because I was so curious about all sorts of things. So I started with biochemistry, and then I went to biomedical engineering, and then I went to computer science, and then to computer systems. When you guys are in college and studying different sorts of things, you'll find all sorts of interesting things that you want to learn about. So when you talk to professors and take classes, sometimes you start to adjust, like, hey, maybe I want to do this or that. So I did take 4 years, but I did a lot of things in between.
What made you settle on like computer systems engineering? Like what was the
So,
deciding factor that was like, oh, this is what I want to do?
so the thing I liked about computer systems engineering is that it had both the computer science side, so I could code all sorts of algorithms and do cool thing with computers, but it also took into account the actual physical computers, right? So sometimes when you're in space, for example, you can't use specific computers because gamma rays hit the computers and mess them up. So I could learn about that side as well in detail. So computer systems was a nice mix of being able to code stuff and working on actual physical stuff, which is super fun.
Yeah. And what made you choose Southwest Research and like moving to San Antonio from Arizona?
So when I interviewed for the Southwest Research Institute, I had done it because I kind of wanted to see what San Antonio was about and what the company was about. And after seeing their facilities and all the cool different machines that they had and all the cool projects they work on, I just had to work here. When I say they work on stuff from deep sea to deep space, I'm not kidding. It's like we work on stuff sending like lunar stuff to space, and then we like work on underwater robots, and then we work on cars and all sorts of things. And I wanted to be a part of everything, so I had to work here.
Yeah, awesome. All right. So for our next question, what made you want to do your current job? From the Gravity Girls in Illinois.
That's cool. That's a really good question. For me personally, I think the things that mean a lot when it comes to jobs is that I'm making a difference, and science and coming up with new technologies and inventing things, which is what I do here, is something that I was that I got pretty good at over time. And so I wanted to use that skill to make the world a better place. And there are so many different sorts of projects that you can work on with computer systems at a job like this that I thought it was a really great fit. It's not the only thing I do for sure, because I have other hobbies and other things that I want to do to make the world a better place. But I really like this job.
Yeah, I love that response because like as somebody who isn't in the engineering field right now, like we don't really see the work that engineers do, right? So because like research
Yeah.
is so far removed, and so I think that's like important, to understand as like engineering affects our everyday lives, even though you might not see it.
Yeah, absolutely. I agree with that. I think a big push for something right now is self-driving cars, for example. And with self-driving cars, you give people who maybe can't drive a car on their own the ability to get places that they otherwise couldn't get. A lot of people who do a lot of driving for work, sometimes they fall asleep on the road. So there are sometimes technologies that I've worked on here that figures out, hey, somebody's getting sleepy in the car. You should wake them up with a beep or something. So it's not just like, oh, we're working on computers. No, we're working on things that people are going to be using every single day. And it affects people's lives. And that's what I really like about my job. Like the things that I do help increase the quality of life for other people.
All right. All right. So working at Southwest Research. So what does a full day at work include?
So one cool thing about the Southwest Research Institute is we work on stuff from talking to customers or talking to clients right from the beginning and working with them all the way to the end. So even somebody like me would have to go out and be like, okay, I need to figure out what does the world need right now. And for example, one of the sections we're working on, or one of the aspects of robotics we're working on here, is autonomous agriculture, right? So that means, hey, how do we farm better? So a lot of farming equipment right now, it kind of drives on its own and does a lot of cool things, but there's still ways we can make it even better. So sometimes my day starts with me sitting down and figuring out, hey, I think there's a small gap in the world here where I think we can make things better. So that's the first part of my job. And then we go out and look for people who would work with us to make that sort of thing happen. And then my favorite part is prototyping something. So prototype is basically not a full system. It's not something that you would put out into the world. It'll be like a small thing that just tests the concept. If you're like, hey, we built a camera that can detect if there are aphids on these plants, meaning aphids are little pests that annoy different sorts of fields. Then we test that out, see if it works, and if it works, then we continue to move forward and do cool things with it. So when it comes to working at Sphere, you do everything. So I really like that about the job.
Yeah, that was a great question from Astro World in Georgia. And I think it's in like, do you like prototype every day? Are you sitting and writing code? Like, what is the,
Yeah.
what do you do most often, I guess?
So there are no 2 days that are the same here. There are some days where I'm coding all day trying to figure out something. Sometimes I'm working on a code and then I get stuck on a problem for like the whole day and I'm trying to figure out how to fix it. Things, you have to learn a lot of things on the job. A lot of people think like, oh, I'm going to go to college and I learned everything in the world and that's it. Nope, you're going to be learning for the rest of your life. You're going to be sitting down, you're going to be opening up textbooks, you're going to be going to the corners of the internet trying to figure out what's wrong with your code. That's something you start when you start coding, you're going to get frustrated and then figure out how to do things. And even when you're working at a full-time job, you're going to be doing the exact same thing. You're always going to be learning. So the only thing that's consistent in all my days of work is that I'm always learning something every single day.
All right. So our next question is about coding. Oops. So what languages do you use to program the pedestrian motion detector, and how does it know there is a person? And this is from Kronos in Florida.
That's a really, really good question. I love the question. So there are different languages that we use for all sorts of different projects, depending on the project. One thing that I think everybody should know is that the C++ language is really generally good for working on like hardware, like actual computers. But Python is really good for prototyping different sorts of things. So those are I think the two biggest languages that we used for this project here. So Python, I would say, was the main coding language we used here. And we were able to recognize the person by using something called neural networks. Neural networks is, so in our brains, we have neurons. And some researchers many years ago decided that they wanted to try to give the computer a brain. So long story short, we gave computers brains, and we basically gave them a bunch of images saying, hey, these are people in the image, and here's where the knee is, and here's where the elbow is, and here's where the head is. And it saw a bunch of these images over time and eventually learned, hey, here's an image, I can find you the ankle and the elbow and the hip of this person. So that's how we found the person in this image. The cool thing about this is after we're able to do that, by taking the angles of all the different elbows and knees, if somebody's going like this, that means they're probably walking in that direction. So by using that, we're able to like predict, hey, people are going to be moving to the left or the right. And that becomes really useful if, for example, autonomous cars are going down the road and a kid suddenly starts running into the street, the computer is able to recognize that super early, which is super, super cool.
Yeah. So so you know how we have like, filters on Snapchat or Instagram that will like be able to put filters on our face. And so the computer is able to like recognize, like where the top of our face is and the bottom. Is that similar to like how the like self-driving car recognizes people?
Not only is it similar, it's almost the exact same type of technology. It's also using neural networks to kind of figure out where a forehead might be or where a nose might be. So yeah, the same technologies you're using for your dog filters on Snapchat are the same exact sorts of technology, but maybe a little bit more advanced for autonomous driving. Yeah, absolutely. Really good comparison. Yeah.
And I'm curious as to what was your first experience doing computer programming, like learning your first like programming language? Like when was that and what was that like?
Okay, so that's actually a funny question because I tell my friends about this all the time. So I didn't start coding until my third year of college because I had started with biochemistry. I was like, oh, I'm probably going to do this. And then so I go into my first coding class and I look at the board and I'm just like, I have no idea what any of this means. And so I'm like, oh, do I really want to do computer science? I don't know. And so I go home that day and I look up a tutorial or two, and then I just basically followed along videos for a day or two, and then I got pretty good at it within those day or two, and I increased my confidence. And then over time, with the classes and everything, I was able to learn to code. I never started coding until college. I know a lot of people have been doing it since they were young. That was not me at all.
Nice. That's like a refreshing story to hear because a lot of times I hear people like coding from when they were very young. So you can learn coding at any age. It doesn't matter when you start. Yeah. And for all the students listening, if like coding and computer science is something that you want to get into and this is a field that you're interested in, you can go to code.org and they have free lessons to teach you guys how to code. And so if you're interested, it's again free and you can start learning how to code like right after this session.
Yeah, absolutely.
So our next question is, when designing a self-driving car, what challenges do you face? And this question is from the Moon Moose in California.
Moon Moose, love it. So there are all sorts of challenges that you have to face when working with autonomous vehicles. I would say the most predominant one is it being able to be safe. So for example, if you are in an area and you have something that can recognize people really well, but it can't recognize other cars super well, how do you balance that, right? And then there are cars that use cameras a lot, and then there are cars that use LiDARs a lot, if all of these people have watched my video. So sometimes people use LiDARs to be able to recognize things, but a LiDAR, for example, isn't really good at figuring out if there's a person 100 meters, like 100 feet ahead of you, but a camera really is, but a camera isn't really good at figuring out if somebody's right next to you or not. So there's all these trade-offs of using different technologies and different algorithms, and trying to figure out the combination that gives you the best result is probably the biggest challenge that I have to face. And on a day-to-day basis, you run into a lot of bugs and you have to learn how to fix them and not get frustrated, but that's a daily task as well.
Yeah. So what are bugs? Do you mean like cockroaches and ants?
Yeah, no, I have like bees all around me all the time. No, I'm just kidding. So bugs are basically little mistakes in the code that people maybe don't notice when they are compiling it. So basically, you write a bunch of code, and then you do something to compile it, which basically means that you take the code and it builds, right? So then the computer can use it. And very often, we'll build something and then we'll run it on the actual car while we're driving outside. And suddenly, instead of recognizing people, it's recognizing birds or something. And we're like, we don't know what we're wrong. And then I have to go back to the code and figure out how to fix that. So that's one example of like a bug. A bug is basically mistaken code.
All right.
And
So
sometimes it's any semicolon that you're missing.
yeah, it can
Yeah.
be all shapes and sizes. All
Oh yeah.
right. So the next question is, how will the existence of self-driving cars affect our community? And that question is from Online Space Pigs in California.
Awesome. Um, there are going to be a lot of impacts. I think, for example, a lot of jobs are going to become different. Like, for example, right now, so many different types of goods are transported across the US back and forth, using trucks. And suddenly, if you have self-driving trucks, those people don't have to do that job anymore. And that creates other different jobs. Or, for example, you can imagine that somebody's driving a car and has a stroke while driving, and the car is able to recognize that. Suddenly, that car can drive straight to the hospital and save that person's life. That's another type of thing. It just opens up the doors to do all sorts of cool things with self-driving cars. And I mean, self-driving car technology doesn't just affect cars on the road. Sometimes it affects farming equipment, or sometimes it affects maybe you want to make boats drive on their own, or airplanes, or whatever it might be. So it affects a lot of things. I wouldn't even be able to tell you everything.
Nice. Yeah, it seems like there's a lot of different like applications that we might not really think of right, right off the bat.
Oh yeah, for sure.
All right. So our next question is, what was your biggest testing and design fail, and what helped you keep going and not give up even if it was really bad and nothing was working? And this question is from the astronauts in New Jersey.
I didn't know we had astronauts in New Jersey. That's really cool. Um, so the specific time that comes to mind is one time I was working with a robotic arm, and it was supposed to basically pick something up and put it in a very specific other place. And it kept grabbing the thing and then like smooshing it, and then it kept grabbing the thing and just doing weird things with it. It started rotating around its own wrist over and over. And I could not understand why it was doing that. And it took me over a week to figure it out. Um, and that project went decently well, but because it was such a novel, or basically a new technology that we were trying to develop, and I had such high expectations for it and for myself, that I got a little bit frustrated. But that's the thing with new technology. Sometimes you do all of this stuff and then you get only a little bit of result. But that little bit of result is going to be super useful for next time when the next person tries and the next person tries. So in engineering, if you're not prepared to fail all the time, you're going to have trouble, because you have to fail all the time in order to get any sort of progress.
All right. Awesome. Great. So for your hobbies, we got a lot of questions about that. So how did your hobby in portrait photography start? And this is from Country People in Ohio.
Awesome. So in college, basically there was a wedding photographer, a company starting, and I asked if I could start shooting with them. And I had never shot professionally before. So they trained me for a short amount of time. And then 2 weeks later, I was flying from place to place and then doing all sorts of portraits and wedding photography, and it was really cool. And then when I got out of college, I decided to continue doing portrait photography because I thought it was so interesting. I'll do it often of my friends or of strangers, try to get a little bit of meaning behind photos and stuff. And it's a lot of fun. It's a lot of fun.
And so my follow-up question to that is that this question is from Star Blazers in Texas. And And they asked, if you could be a photographer and still be an engineer for the Perceptive system section, would you do both as a job, or would you just be an engineer?
I think a lot of people get the impression that when you're an engineer, suddenly you're stuck in a box and you can only do math and code all day. That's not the case at all. There is no such thing as being a specific type of person or having only one career. I still do photography. Sometimes I'll go out and do shoots on the weekend when I have time, or maybe after work or before work. Um, so I kind of already have both jobs right now. I get to choose how I want to balance that. If I want to be a photographer, astronaut, engineer, biker, then I can be that.
Yeah, I think that's a really great point to bring up, is that, you can still have your personal life and your hobbies and still have your full-time job.
Exactly.
All right, last but not least, I got a lot of questions from you guys on this. What is bouldering? What is it? How is it done? And where do you go to do it? And this is from Shouting Star in New Mexico.
Great question. Bouldering is basically rock climbing without the ropes. So basically, there are these places, usually indoor, but you can also do it outdoor, and I'll explain how in a second. But basically, there are these indoor gyms full of rock climbing things, and at the bottom, there is this thick, thick mat that you can fall down on. So the reason I think a lot of people like bouldering is that there's no ropes attached to you, and you can jump from rock to rock and do all sorts of fun things. I really, really enjoy it, and I've been doing it for a little while. There's a great place here in town that I go to, but you can find them in a lot of cities.
Very cool. All right, and then the question we ask all of our speakers that come on here is, if you were taking a trip to the moon and could only bring one item from home, what would it be? Only bring one thing.
I'd probably bring a camera that was space proofed because I have to take a lot of photos. That's what I do.
Perfect. All right, Natasha, do we have any last minute questions?
Yes. So there's a student that's really interested in your job, and they want to know if you have any advice for someone looking to be in a role like you have.
That's a great question. I would say my biggest piece of advice is, well, I have two. One, continue to be curious and learn and read about things wherever you're at. And secondly, once you do go to college, if you do get a chance to go to college, you should definitely talk to your professors. I wish I started doing it my third year, but I wish I started doing it my first, because professors are always super excited to talk about what they're doing, and professors will be like, hey, I'm working on this. Do you want to help me with it? So having those connections and being able to be friends with your professors is just such a great thing. I would highly recommend it.
Very cool. All right. Well, thank you so much for joining us today, Ridhwaan. I know the students really enjoyed it and they had so many amazing questions, so thank you.
Yeah, they had amazing questions. Thank you guys so much for having me.
All right. So we will jump into something I know everyone is waiting for. Natasha?
Okay, so thanks for sticking around to watch first our highlights, and then we'll get to our raffle winners. So you guys, I know this was a hard challenge. So this is the robot hand design, and we've been watching all your videos. I've been talking to your teachers, and I know some of you guys are really struggling with this activity, but we were in, what is this, week 5? So we wanted to give you a real challenge here, a real good engineering design challenge. And I am thankful that you persevered. Our speaker just talked about failure. I know you experienced a lot of failure in trying to get this robot hand to pick up an object, which was actually the example story given. So I'm very impressed though with the final design. So go ahead, Aspen, let's play our highlights reel. All right, so this week you guys are working on your rovers. So you're trying to get this little robotic device that connects with the vibrating motor and the battery and getting that to move an object like a ping pong ball. I've already seen some submissions. You guys are doing an awesome job. So I look forward to seeing your work there. But let's move on to our prizes. So this week we're gonna have one winner because we have a really awesome prize. It is this Hydrobot arm kit. We thought this was a perfect prize since you guys were working on this robot hand design, and it is powered by water. So it's hydraulic. You will put together this kit and then you pull these levers and it moves and it picks up objects. So I just thought this was a cool prize. Okay, let's see who our winner is. So the Mission 5 raffle winner goes to, dramatic drum roll, Voorhees Cosmonaut Team in New Jersey. Congratulations, guys. Awesome job. As a reminder, keep going because we're almost done. So we have 2 more missions left. So you guys are working on this mission 6, the rover. Then there's mission 7. We have a break for Thanksgiving, and then we have mission 8. If your team can earn 25,000 points or more, you will be entered in the big raffle. The school can win a model rocket kit, robotics kits, 3D printer. We've got some really cool prizes. So hang in there. I've loved seeing all your designs and keep going. So that's what we have for you this week, and we will see you next week. Thanks, guys.